Coral reefs are bleaching and dying, but not how you would expect. Why should we care? Let's dive in and take a look.
Coral reefs take up less than 0.1% of the ocean, but contain over a quarter of marine species. A single reef can support over 1,000 species of plants and animals, with the largest, the Great Barrier Reef, supporting close to 7,000 different species. They provide billions of dollars to the economy through coastal protection from natural disasters such as flooding and tsunamis, as well as providing food, tourism, and medicine to coastal communities.
Corals are made up of thousands of tiny jellyfish-like organisms called polyps. They have a symbiotic relationship with photosynthetic algae called zooxanthellae, which provide the polyps with nutrients and their bright colours. During coral bleaching, the algae are expelled from the polyps as a defence mechanism, leaving the skeletal structures with a bleached appearance. This causes part or all of the coral to die off, reducing coral cover and significantly disrupting the reef ecosystem.
Corals are currently at significant risk of bleaching due to climate change, which is causing increases in sea surface temperatures and decreases in the pH level of the ocean. This is increasing the frequency and intensity of coral bleaching events.
A study by Sully et al. In 2019 measured coral bleaching across over 3,300 sites across the tropics, including coral reefs in East and West Africa, the Red Sea and Arabian Peninsula, India, Southeast Asia, Australia, the Pacific Ocean, the Caribbean, and Brazil. White circles indicate where no bleaching has taken place, and the yellow circles indicate where 100% of the corals studied had been bleached.
The study found that coral bleaching has increased in frequency and intensity over the past decade. Interestingly, the onset of this bleaching has occurred at higher temperatures in the last decade compared to the decade before. This suggests that coral populations are adapting or acclimatizing to higher sea surface temperatures. However, the increase in coral bleaching is not the same everywhere.
There is significantly more coral bleaching in mid-tropical latitudes around 15 to 20 degrees north and south of the equator. On the other hand, corals in equatorial regions experience less bleaching.
So, why are equatorial regions seemingly better for corals? Firstly, the kinds of corals found across equatorial areas might be more resistant to bleaching or better suited to the local conditions, making them less likely to be affected by the environmental factors that lead to bleaching.
Secondly, in equatorial regions, there could be a greater variety of coral genetic types, including some that don't easily get stressed by heat. Having this genetic diversity could act like a natural defence system during bleaching events.
Finally, some corals in equatorial regions might already be used to high temperatures because it's consistently warmer there. This pre-adaptation may have made the corals tougher and less likely to bleach when the sea gets unusually warm.
In both regions, corals tended to bleach less when there was high temperature fluctuation on daily, weekly and seasonal scales. This may lead to reefs harbouring corals that are more resistant to temperature extremes.
Now, if you're wondering what predicts coral bleaching, in short, it is faster temperature changes that lead to more coral bleaching. Global models predict that sea surface temperatures are on the up. In fact, they predict that future annual increases in ocean temperatures will be double that of the last 30 years. This means that a greater area of coral reefs will experience bleaching.
But it's not all doom and gloom. Equatorial regions and locations with massive temperature swings could be our coral saviours. These spots might hold the secrets to resilient coral reefs. We must think about conservation to protect them and help restore damaged coral reefs.
So, how do we go about doing this? Some organisations like the National Oceanic and Atmospheric Administration, or NOAA for short, have been creating coral nurseries by growing coral on tree-like structures which will later be transplanted into existing coral reefs. This can help warm water corals move to damaged reefs.
Some scientists have introduced heat-resistant corals to regions with less resilience. The goal is for the offspring of these hardier corals to pass on their resilient traits to the less robust coral species in those areas, potentially increasing the overall resistance of the reef.
But conservation efforts have their limits. The most significant threat to corals is climate change. One study noted that without significant emissions reductions, the future of coral reefs is increasingly bleak. Therefore, regardless of the resistance of specific corals and our conservation efforts, coral reefs will face extinction unless we take decisive action to halt climate change.